Your team reviews every line it writes, then ships an application containing hundreds of components it did not write. One routine dependency update passes through the build system and reaches production. Later, you learn the package source was compromised. Software supply chain security asks a simple question: can you trust how software was selected, built, packaged, delivered, updated, and operated, not only what the source code looks like? In this video, we will map the chain, compare vendor reviews, software inventories, SBOMs, signatures, provenance, build controls, and runtime containment. We will use a fictional update incident and build a practical program for beginners. No control eliminates all third-party risk, and a familiar vendor name is not proof that every component or update is safe. Clear supply chain explainers start with one trusted update, reveal the hidden dependency graph, show where trust can fail, compare controls by purpose, and return to a concrete incident response. Visuals move from source to build, package, registry, deployment, and operation. We adapt only those general teaching techniques. This script, fictional example, diagrams, artwork, thumbnail, branding, and scene composition are original to CipherVibe. Here is the analogy. Software is a restaurant meal. The menu is the product name. The SBOM is an ingredients list. Provenance records where ingredients came from and how the kitchen prepared them. Signatures help verify who sealed the delivery. Testing checks the finished dish. Runtime controls limit the damage if something unsafe remains. A recall plan tells you which customers received which batch. An ingredients list is useful, but it does not prove the kitchen was secure or the food is safe. Supply chain defense needs inventory, integrity, process, containment, and response. The chain begins with requirements, developers, source repositories, dependencies, and external code. It continues through developer devices, continuous integration runners, build tools, secrets, artifact storage, package registries, signing services, and release approvals. Distribution adds update servers, mirrors, app stores, content delivery, and vendor support. Deployment adds automation identities, infrastructure templates, containers, and privileged installers. Operation adds cloud services, APIs, agents, plugins, data processors, and fourth parties used by your vendors. Threats include compromised maintainer accounts, malicious or abandoned packages, dependency confusion, tampered build systems, stolen signing material, poisoned updates, vulnerable components, excessive vendor access, and unsupported products. Start with data flow and privilege. What can the software access? How broadly is it deployed? Does it update automatically? Which business service depends on it? How quickly can you identify, isolate, replace, or recover it? A questionnaire is not a control unless its answer changes selection, design, contract, monitoring, or acceptance. Tier suppliers by impact. A public design library and a privileged endpoint agent should not receive identical review. Consider sensitive data, production access, tenant isolation, update authority, concentration risk, geographic and legal constraints, recovery time, and substitutability. For higher-risk software, ask how development environments are secured, dependencies are governed, vulnerabilities are disclosed and remediated, artifacts are protected, releases are authorized, incidents are communicated, and products are supported at end of life. Request evidence appropriate to the risk, without assuming a certification proves every product or period. Contracts may address notification, support, vulnerability handling, evidence, subcontractors, data use, secure deletion, audit rights, business continuity, and exit assistance. Legal and regulatory requirements vary, so involve qualified procurement, privacy, legal, security, engineering, and business owners. An asset inventory tells you which products and versions you operate. An SBOM adds a nested inventory of software components. CISA describes SBOMs as a key building block for transparency and risk-informed decisions. They can help answer, where is this component deployed? An SBOM is not a vulnerability scan or proof of integrity. It must be current, machine processable, mapped to actual deployments, and correlated with advisories and context. A digital signature can help verify that an artifact came from the expected signing identity and was not altered after signing. It does not prove the signer or build was uncompromised. Provenance records information about how an artifact was built. Stronger approaches isolate builds, protect identities, and make attestations verifiable. Testing, code review, Dependency analysis, sandboxing, policy gates, and runtime observation answer other questions. Use the controls together: inventory for exposure, provenance and signatures for integrity history, testing for behavior, policy for acceptance, and containment for residual risk. NIST's Secure Software Development Framework organizes high-level practices that producers can integrate into their development lifecycle. It includes preparing the organization, protecting software, producing well-secured software, and responding to vulnerabilities. Protect source control with strong authentication, reviewed changes, branch protections, minimal automation permissions, and monitored administrative actions. Separate developer, build, signing, and deployment identities. Keep secrets out of source and short-lived where possible. Control dependencies with approved sources, locked versions, review of material changes, and deliberate update windows for critical systems. Generate an SBOM during the build, preserve build logs and provenance, sign releases through a protected service, and verify artifacts before deployment. Use isolated, ephemeral build workers when feasible. Restrict network access and avoid allowing an untrusted build step to reach unrelated secrets. Critical releases may need multiple approvals or staged promotion. Exact controls depend on language, ecosystem, delivery model, threat, and operational tolerance. HarborWorks operates a fictional scheduling service. A routine library update introduces a new transitive component. The component is not on the approved source list, and the build cannot produce the expected provenance record. The pipeline does not claim the package is malicious. It stops promotion because required evidence is missing. Engineers compare the dependency graph with the previous release, review the change, and rebuild from approved sources in an isolated environment. The updated artifact passes tests, produces a current SBOM, carries a verified signature and provenance record, and moves to a small canary group. Runtime monitoring shows no unexpected network destinations or privilege changes. The team then expands deployment gradually. Days later, an advisory affects the transitive component. HarborWorks queries its deployment inventory, identifies only the canary batch, isolates it, rolls back, preserves evidence, and notifies the vendor through the defined process. No single tool saved the company. The combined system provided visibility, a decision gate, limited blast radius, and a fast recall path. At deployment, verify the artifact again. Use staged rollouts, canaries, change windows, health checks, and rollback criteria. Restrict the software's network, file, identity, and administrative access to what the service needs. Monitor vendor identities, service accounts, new integrations, update activity, unusual egress, privilege changes, and security control disablement. Automatic updates may reduce exposure to known vulnerabilities, but critical systems may require controlled promotion and rapid emergency paths. Prepare for supplier incidents. Know the product owner, technical owner, contract contact, security contact, deployed versions, data flows, dependencies, recovery procedure, and alternative. Preserve advisories, logs, artifacts, hashes, SBOMs, provenance, approvals, and timelines according to the incident plan. Response decisions may include disabling an integration, revoking vendor access, blocking an artifact, isolating systems, rolling back, rebuilding, rotating secrets, increasing monitoring, notifying stakeholders, or accepting time-limited residual risk. Common mistakes include reviewing a vendor once and never monitoring change, treating all suppliers equally, accepting marketing claims without scope, collecting SBOMs without validating or using them, scanning components without prioritizing exploitability and business impact, and allowing vulnerable or unsupported software to accumulate without an owner. Do not expose sensitive SBOM, architecture, build, or vendor access data. Protect it according to its contents and sharing purpose. Do not publish signing keys, credentials, internal package names, or exact defensive gaps. A signature is only as trustworthy as the protected signing identity and process. A clean scan is point-in-time evidence, not a guarantee. A low-severity dependency may be important in a privileged context, while a listed vulnerability may be unreachable in another. Avoid concentration risk and irreversible lock-in. Test backups, data export, replacement, revocation, and contract exit. Finally, do not make developers choose between security and impossible delivery deadlines. Secure defaults and automated, explainable guardrails scale better than emergency exceptions. Here is the supply chain checklist. Know what software, services, components, versions, vendors, and fourth parties support each business service. Map data, privilege, update authority, criticality, ownership, and replacement options. Tier risk. Put security requirements into acquisition and design. Evaluate supplier practices and evidence in proportion to impact. Use NIST SSDF or another appropriate framework as a shared vocabulary, not a checkbox promise. Maintain deployment inventory and usable SBOM data. Protect source, builds, secrets, signing, registries, and releases. Verify signatures and provenance where supported. Test behavior and enforce policy before promotion. Limit runtime privilege, stage updates, monitor change, and keep a rollback path. Prepare vendor contacts, incident decisions, notification paths, evidence collection, and alternatives before a crisis. Remember the restaurant, the ingredients list, kitchen history, sealed delivery, safety checks, serving controls, and recall plan all matter. Supply chain security does not mean trusting no supplier. It means knowing what you inherit, demanding useful evidence, limiting blast radius, and being ready to replace what fails. Copyright 2026 CipherVibe. All rights reserved.